Okay, so what is a differential amplifier? Differential amplifier is basically an amplifier that takes the difference between two voltages and then amplifies it. In the case of an op-amp, I've stated in a previous video that the definition of an op-amp is a differential amplifier with an inverting input and non-inverting input, such that it takes the difference between the two to produce the output. But in the previous videos, what we have been doing is using this differential part of the op-amp to actually create a feedback to linearly amplify a single voltage to our desired gain. But in this video, what I hope to do is explain how we use the op-amp to take the difference between two voltages, V1 and V2 in this case. Okay, so if we do the same thing as we did for the negative feedback op-amp, we're going to take our current through the top part here, and by op-amp rule number 1, no current goes into the op-amp, so we can define positive and negative for the two voltage drops and current I1 and I2. Nodal analysis says I1 must equal to I2, and so using Ohm law, how can I derive I1? Well, that is V1, which is the node over here, minus, okay, by the second rule of the op-amp, the two terminals must be the same voltage. If this input is V2, that means this input must be at V2. So then by Ohm's law, then V1 minus V2 over R1 should give me the current I1, and I2 should give me V2 minus V1 over RF, which gives me over here I2. I play around with the equation. I can multiply by RF, move V2 to the other side, and then I'm going to have this form. And then if I rearrange this by multiplying by negative and taking common factor, I get V out is going to equal to some number, which is I1 plus RF over R1, times V2 minus some constant over here, which we can adjust, RF over R1, times V1. In other words, this thing is taking the difference between V2 and V1. It's V2 minus V1, but except that it's taking different gains of them. So in this case, we can play with a ratio that we subtract. So I can say, like, I can take 2 of V2 and 3 of V1 by just playing with the RFs and R1, the resistance. Okay, so now we're gonna go a little theoretical here now. Let me define V input, the difference input, to be V1 minus V2. Well, that makes sense. The difference is V1 minus V2. And let me define something called the common mode input to be the average of the two voltages. And what the common mode input basically is undesirable, at least to say, it's undesirable, but what's happening and how it occurs is the V1 and V2 over here. If these two voltages are the same, let's say 10 and 10 volts, then we can say then that these two would have a similar voltage, but we would get the voltage difference between these two to be 0. So ideally, we're supposed to have 0 volts. But because this is 10 volts coming at the input terminal is seeing 10 volts, the fact that it is seeing 10 volts and not 0 volts means that it will produce an output. And this is undesirable, not ideal. So what we really want is the common mode voltage to be 0. Sorry, the common mode voltage gain to be 0. We're always going to have a common mode voltage, but we want the gain of this to be 0. So how do we do that? So if we transfer this side to this side, we're going to have V1 should equal to a half of that difference plus the common mode, and V2 should be negative a half of that difference plus the common mode. And so what does that mean, you say? Basically, it's like deriving backwards from this equation. if I would say, let's say, a common mode, in other words, an average, the two numbers V1 and V2 average out to be 6, and the difference between V1 and V2 are 4, well, you can solve that. V1 must have been 8 and V2 must have been 4 to have a difference of 4 and an average of 8. And so this is what the equation is saying. If I have that difference of 4, then I can just use this equation to like basically saying the same thing. Well, then we know the output then will be a gain of the V input plus the V1 and plus a second gain of the V2, depending on the ratio, as you can see here. We can play with that. But what if I plug these two into here? Well, then I get this. V1 and V2 will be replaced. And then when I simplify it, I'm going to be left with the equation in terms of the V input difference and the common mode difference. So if I put V1, I put this whole thing in here and this whole thing into here, then I'm going to be left with I1s and I2s because there's both common modes in these two areas. And then when I simplify it, I get I1 minus I2 over 2, right here, times the differential input, plus A1 plus A2 times the common mode input. But we want the output to be 0. So ideally we want to find some voltage, some gain combination of these two so that the gain would be 0. The common mode gain would be 0. So by this equation we can see clearly here, the common mode gain would be the gain of the first input plus the gain of the second input, and then the differential gain would be the first input minus second input divided by 2.